All right, good day, everyone. We have two papers that are for our notes because today we're talking about squares and rhombus, or rhombus, whatever you want to call it. So if you have a printer, you want to print both of these out. If you do not have a printer, you will just have to copy. Don't worry about the 6-3, just call it notes. You would just have to copy all the examples into your journal, okay? And when I say examples, that means I want every single problem with all the words in the picture and the worked out, okay? So that would just be directly copied. The people with printers, you print it out, you write directly on the handouts like I'm doing, and then you'll either tape or glue them into your journal. So we're gonna start with the rhombus notes, and then also when I am done, as you can see, I have two of the properties filled in. I will go back at the end of my notes. I won't do it with you guys on, and I'm gonna fill in the rhombi, and I'm gonna fill in the squares, okay? So let's go ahead and get started. Make this a little bit bigger. Okay, so a rhombus is a parallelogram with four congruent sides. So you can just make a sketch. Okay, so that means all the sides are equal. These are the properties, so I'm just going to read through them. And this is what you do refer to as you're working the problems out. So again, opposite sides are parallel, okay? Opposite sides are congruent, all right? Opposite angles are congruent, all right? Consecutive angles are supplementary, okay? Diagonals bisect each other, okay, that means those are equal. Four congruent sides, that means all the sides are equal. Diagonals are perpendicular, that means they add up to 90. Diagonals bisect opposite angles. Okay, so we got it. So now we're just going to come through here and start working out some of the problems. All right, example 1 says, if the measure of angle RST is 67, so RST, this whole thing here, is 67. Find the measure of RSW, all right? So RSW, okay? So we remember it says that diagonal bisect each other. That means they're equal half. So I can just take, to get the angle RSW, I can just do 1/2 of it. And it's 33.5 because those two halves have to be equal. So that means they both have to equal to 67. All right, let's look at example 2. Example 2 says find the measure of SVT if the measure STV equals 135. So STV, that means this whole thing here is 135. Okay, that means this one's 135 here. All right, and I need to get SVT. SVT, that means there's this little half right there I want to find. All right. So first thing I can do is figure out, these are add up to 180 because it says that in the rules. So I can just do 180 minus 135, and that gives me 45. But that's actually the whole thing here. This whole thing is 45. But I don't want the whole thing, I just want half. So to find the measure of STV, I would do 1/2 of 45, which turns out to be 22.5. So you kind of just have to think about the rules and apply them. And don't forget, all I'm doing is referring back to the properties to figure these out. Okay, example 3. Example 3 says the measure of SWT right here is 2x plus 8 degrees. Okay, find x. Okay, well, if we look over here, it says that diagonals bisect each other. So that pretty much means that, and the diagonals are perpendicular, so that means that these are 90 degrees. So all those are 90. So I can just do 2x plus 8 equals 90. Take away 8 from both sides. 2x equals 82. Divide that, x equals to 41. Okay? And that's it. All right, let's look at example 4. All right, example 4 says, what is the value of x if the measure of WRV equals 5? WRV, so this angle right here, okay, is 5x plus 5 degrees. All right, and the measure of angle WRS right here is 7x minus 19. All right, so if you come back here, you can just see some of the rules, and those are going to be congruent. okay, because they bisect. So they're just congruent, so you just need to set them up with the equals. So we're going to do 5x plus 5 equals 7x minus 19. I should have did the 7 on the other side, but that's okay. So I'm going to take away the 5. So now I have 5 equals 2x minus 19 plus 19 to both sides. So now I have 2x equals, what is that? 24. Divide the 2 out, x turns out to be 12. All right, the last one is this one here. We're going to fill in all this stuff. It says if rhombus DLMP, okay, DM, that means its entire length here is 24. So that means that these are 12, 12 each, okay? The angle of LDO is 43. And DL is 13. All right? So that means these are 13, like that. And we already know that this has to be 90 here, down here. All right? So let's see if we can fill some of this in. Okay, OM. All right, OM, I already said this full length was 24, and I already split it in half, so OM is just 12. Angle of DOL. DOL, well, we already know that all these are 90, so that's 90. Okay. Angle of DLO. DLO. Okay. So, first off, I need to just figure out what these are. So, I did 180. We know these are consecutive, so I can just minus 43, which gives me 94. That's the full thing will be 94. Okay, so I don't want the full thing, so I'm going to do 94 divided by 2, which gives me 47. So that means for DLO is 47, because the full thing is 94. All right, and now we're looking for angle DML. DML. Okay, so this is 43 here. This is 43, this is 43. So that's just 43. And then DP, well, we know all the sides are congruent, so that just has to be 13. All right, and again, all I did, sorry about that, I think that got cut off for a second. All I did was I just used the properties. So that's why the properties are super important. You just need to refer back them to help you figure out the different rules. And I always draw on my pictures to make it easier. That's why I always said to have the pictures on the paper so you can actually write on it. All right, let's do squares. Most of you guys can do the squares without me even going over the notes because you guys have done that multiple times. But we're going to go ahead and do some notes on squares anyway. All right. So a square is a parallelogram with 4 congruent sides and 4 angles. So just everyone make a square. Just like that. All right, and then let's just read right here what it says. It says, because a square is a special parallelogram, it has all the properties of parallelogram, in addition to those of a rectangle and a rhombus. So that's why it has so many properties. Again, you want to transfer this onto your property paper at the end. I'm just going to go through here and read them. You guys do need to have these properties. Now, if you are writing by hand, you don't need to write these out each time per note if you're transferring them onto here. If not, then yes, you have to copy this directly into your journal. All right, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. That means you guys, all right. Diagonals bisect each other. That means they're congruent. 4 right angles, that means all these are 90. Diagonals are congruent, so that means these are equal. 4 congruent sides, that means all the sides are the same. Diagonals are perpendicular, so that means 90, 90, 90. Diagonals bisect, so that means these are congruent. All right, so now we're just going to go ahead and try to do some square problems. There's not that many examples. As you can see, there's only 2. Example 6, again, you do need to copy the entire thing, and you need the picture. So let's just look at it. It says math is a square. M-A-T-H is a square. All right, so if M-A equals 8, then A-T also would have to be what? 8, because all these are the same. All right? It's H, okay, the measure of HST. HST, okay, angle HST. Well, we already know that these are bisecting, so these have to be what? Are 90s. All right? And then the measure of MAT. MAT. Okay, well, right here, if we go to the properties, we know those are also what? 90. All right, and it's saying if HS is 2, then HA would be what? So both of these have to be bisected, so there's 2, 2, so the entire length would have to be what? 4. And so these are congruent. This is 4, that's also what? 4. And again, all you do is go back and look at your properties. I kind of have the properties memorized. If you don't have them memorized, which you don't yet, you just need to have the properties in front of you. That's why I said while you're doing your work, it works a lot if you just have these right there in front of you. All right, let's look at example 7, and then this is our last one. We're going to solve A and B. Okay, use square ABCD and the given information to find each. Okay, so if they're saying the measure of AED is 5, this thing right here, 5x plus 5, find x. Well, we already know from the rule that these are bisecting, these are 90 each. So we can just do 5x plus 5 equals 90, right? Then you take away 5 from both sides. So 5x equals 85. Divide 5 out, x turns out to be 17. All right, let's see what B asks us to do. If the measure of BAC is 5x, find x. Well, we already know that this entire thing is 90, and we have half of it, so I can just use 45. So I can just do 5x equals 45, divide 5 out, x turns out to be 9. All right, that's it for your notes. So make sure you get all these examples copied into your journal. If you have a printer, obviously write them down on the paper and then get this glued into your journal. All right, go ahead and start your classwork. Don't forget afterwards to start copying the properties. I'm going to do that right now. All right.